Welcome to Canerica's podcast, The Digital Shift.
Great to be here. Today, we're really diving into something critical, the absolute need for real-time data analytics. Speed isn't just an advantage anymore. It's, well, pretty much the only currency that matters in many sectors.
Right. Think about financial trading or smart devices personalizing things instantly. Waiting minutes, it's just not viable.
It's economic suicide in some cases.
Yeah.
And for years, businesses were stuck with this awkward trade-off in their data architecture.
Exactly. You had data lakes, cheap, flexible storage, great for raw data. And then you had data warehouses, structured, reliable, but slow for reporting.
You basically had to pick one.
Yeah.
Speed or accuracy. And the whole process, it was often fragmented, disjointed. Businesses were waiting hours, sometimes days, for insights that were, frankly, already out of date.
History, not insight.
Precisely. And the market saw this gap very clearly. We saw huge validation, didn't we, when Databricks pulled in that massive $10 billion Series J funding round back in October 2024.
Yeah, that pushed their valuation to, $62 billion? $62 billion. That kind of money signals intense demand for platforms that don't just hold data, but deliver intelligence, instantly from live data streams.
So our mission today is to unpack how Databricks Lakehouse architecture tackles this exact problem. We want to look at how it brings together data engineering, machine learning, analytics, all under one roof.
And, importantly, what that means for your business, for your ability to actually use data effectively. We'll focus on the real impact and the key takeaways.
Okay, let's get into it then. Unpacking the Lakehouse. If those old systems were all about separation lakes here, warehouses there, what makes the Lakehouse fundamentally unified? What's the core difference?
Well, the fascinating thing is that the Lakehouse basically just eliminates that separation completely.
No more split.
No more split between raw storage and curated analysis. It merges them. So you can run streaming jobs, complex analytics, even AI workloads, all simultaneously, right where the data lands. Okay, but hold on. If you just merge them, data lakes had a reputation, right? They became data swamps. Unreliable, messy. How do you combine them and still trust the data?
That's the crucial innovation here. You keep the flexibility and the low cost of cloud data lakes, yes. But Databricks layered on top the kind of trust you'd expect from a data warehouse. And they did that primarily using Delta Lake.
Delta Lake.
Delta Lake is key. It provides ACD properties, that's atomicity, consistency, isolation, durability, directly onto those cheap cloud storage buckets.
So the reliability of a database but on lake storage?
Pretty much.
Yeah.
That operational headache, that trade-off businesses always face between cheap storage and reliable, governed data, it's essentially gone with this model.
Okay, reliability is one thing, but it also has to be fast. We keep hearing about real time. You mentioned the Photon engine giving big performance boosts. How does that work with streaming data? Doesn't using serverless compute add delays while things spin up?
That's a really good question, and it touches on some clever engineering. Photon is it's a vectorized query engine written in C++A, super fast. It speeds up SQL queries dramatically, so you get near-instant results for dashboards, ad hoc analysis, that kind of thing.
And the serverless part.
Right. Serverless compute is designed to autoscale almost instantly. It anticipates the data flow, keeps clusters warm and ready. So you avoid paying for idle resources when demand is low.
Saves cost. Okay.
But crucially, when a huge spike of streaming data hits, there's basically zero noticeable delay in processing power being available. The aim is predictable, fast query performance no matter how volatile the workload gets.
Got it. So the Lakehouse provides the unified, fast, reliable foundation. But like you said, just dumping data in, even reliably, isn't enough. How do you maintain quality and structure with data flying in constantly?
Discipline comes from structure. And Databricks enforces that using what they call the Medallion model. It's a really clear, structured approach for quality control. It organizes data processing into 3 distinct zones or layers.
Medallion model.
Okay, yeah, bronze, silver, and gold. This structure ensures that anyone using the data downstream gets high-quality, trustworthy information.
Okay, walk us through those layers. Why is that specific flow important, especially for real-time stuff?
Sure. So first up is bronze. That's the raw data zone. It's the first stop for data coming in from sources, IoT sensors, payment APIs, Kafka streams, whatever.
Just lands there.
Lands as is, no changes. You preserve the complete raw history. The key idea here is having an immutable record of exactly what arrived when.
Okay, raw and complete. Then
it moves to silver, the refined data zone. This is where the real data engineering work happens. We cleanse the data, enforce schemas, apply business rules, maybe enrich it by joining different streams together.
So cleaning it up for use.
Exactly. The tables in Silver are clean, reliable, and ready for operational analytics. Critically, downstream users don't have to worry about things like missing fields or weird formatting.
Makes sense. And finally,
Finally, Gold. The business data zone. This layer takes the refined data from Silver and aggregates it, creates highly summarized, performance-optimized tables tailored for specific business needs or metrics.
so this is what the BI tools hit.
Precisely. Or application dashboards. It's designed for super low latency queries because all the heavy lifting, the cleaning and joining, happened upstream in Silver. The data here is ready for immediate consumption.
Right, and the engine driving data through these bronze, silver, gold layers automatically is Delta Live Tables, or DLT. What makes DLT different from just writing traditional ETL scripts?
DLT is, well, it's a bit of a game changer for pipelines. You define your transformations, what needs to happen to get from bronze to silver, silver to gold, using SQL or Python, in a declarative way.
Declarative, meaning you say what you want, not how to do it step by step.
Exactly. You state the desired end state for each table. Then DLT automates the actual pipeline management. It figures out dependencies, handles errors and restarts, scales the compute clusters up and down.
So less babysitting the pipeline.
Way less. It builds the necessary DAG as. The directed acyclic graph monitors everything and continuously updates your tables as new data streams in. It's continuous processing without all the usual manual operational headaches.
Okay, the theory sounds solid. Unified platform, structured flow, automated pipelines. But implementing this globally, making it work in the real world, that's the challenge. How does this translate into actual business outcomes?
Yeah, and we have some really powerful examples that show the shift from slow reports to live intelligence. Let's take logistics. Pelabuhan, Tanjung Pelepis, PTP, a huge port in Malaysia.
Right.
They were struggling. Critical decisions, which crane needs maintenance now, where to stage the next ship's containers were based on reports that were hours late. Why? Because they had data stuck in like 10 different disconnected systems.
An hour's delay at a massive port that causes ripples everywhere, doesn't it? They needed live intel, not old reports.
Absolutely. So they implemented the Lakehouse, unified all those operational data streams, built real-time dashboards covering logistics, maintenance, even workforce allocation.
Yeah, and the results?
Reporting time for those critical operational views went from several hours down to just minutes. They shifted from reacting to yesterday's problems to actually managing things proactively, right in the moment.
That's a huge operational difference. Okay, what about consumer tech? You mentioned Tonal.
Yeah, Tonal, the smart home gym company. They needed to stream workout data from their equipment and analyze it instantly. Not minutes later, but right now.
To personalize the workout.
Exactly. To give immediate feedback, adjust workout intensity on the fly using machine learning models. Their old batch processing approach was just way too slow for that kind of dynamic experience.
So latency was killing the user experience.
Right. Using Databricks, particularly MLflow for managing the models, they cut that latency for user analytics down from minutes to mere seconds. That dramatically boosts user engagement because the workout feels like it's adapting to you in real time.
Those are compelling examples. But bridging the gap, going from a proof of concept to a fully operational, governed production lakehouse, that requires specific know-how, doesn't it?
It absolutely does. And, well, this is really where we come in. At Canarica, we partnered directly with clients to bring this lakehouse architecture to life.
Yep.
Our expertise lies in combining the AI strategy, the data engineering best practices, and importantly, the secure cloud infrastructure setup needed to deliver these custom lakehouse blueprints. We focus on building trusted data pipelines, implementing robust governance, using tools like Unity Catalog.
So you handle the end-to-end implementation.
We help clients move smoothly from maybe just experimenting with this stuff to having a high-performing, secure, production-ready system. We help optimize the whole stack for performance and ensure it meets all the necessary compliance rules. That's what we at Canarica do.
Got it. So moving beyond just faster reporting or cleaner data, you mentioned the intelligence layer, prediction. If the data's flowing in real time through this unified system, how does the AI and ML part actually get integrated? Is it bolted on or built in?
It's fundamentally built in, thanks to Databricks ML and MLflow. Because processing and storage are unified in the Lakehouse, you don't need that extra step of exporting data to some separate system just to score it with a model.
So the models run directly on the streams.
Directly on the streaming data flows within the Lakehouse. This makes implementing automated predictive scenarios much more seamless. It all happens in the same environment.
Okay, give us a high-stakes example. Where does millisecond timing really matter?
Real-time fraud detection is probably the classic case. Think about live data streaming in from payment systems.
Transaction data.
Exactly. Trained ML flow models can score those incoming transactions instantly, literally in milliseconds, to assess the risk level. Based on the score, you can trigger automatic holds or alerts, or maybe request step-up authentication.
So stopping fraud before it completes?
Precisely. It's a huge shift from the old way, where you might detect fraud hours later in some batch analysis. This is live prevention, happening while the transaction is still in flight.
Powerful. Any others?
Predictive maintenance is another big one, especially with IoT. Sensor data streams continuously from, say, factory machinery or wind turbines. ML models constantly monitor this flow, looking for tiny anomalies or wear patterns that predict a future failure.
And trigger alerts.
Trigger alerts automatically.
Yeah.
So maintenance shifts from being reactive, waiting for something to break, to being proactive and predictive. That saves enormous amounts of money and prevents unexpected downtime.
Okay, makes sense. But as you scale this, especially with sensitive data and real-time decisions, governance becomes paramount. Centralized control, security. Unity Catalog is Databricks' answer here, right? But how does it provide that fine-grained control without just bogging everything down in red tape?
Yeah, that's the perennial challenge.
Yeah.
Security versus speed. Unity Catalog was really engineered to enable secure speed. It acts as a single, unified layer for all your metadata, your data lineage tracking, and crucially, that fine-grained access control.
Down to rows and columns.
Down to the row and column level, yes. But the key is that this governance is managed centrally. Data owners set policies once, and Unity Catalog enforces them consistently across all workspaces, all users, whether they're running a Python notebook or querying from a BI tool.
So engineers don't have to manually juggle permissions everywhere.
Exactly. It standardizes governance, taking that burden off individual teams. This means security and compliance don't become bottlenecks that slow down innovation and delivery speed.
Right, that makes sense. So pulling this together, for someone actually building and running these critical high-speed systems, what are the absolute must-dos, the non-negotiable best practices to ensure these things are reliable, governed, and don't break the bank?
Well, the focus really has to be on reliability and efficiency. First, I'd say design streamlined pipelines using declarative logic. Really lean into DLT's declarative nature. Don't get caught writing complex manual orchestration code to find the what. Let DLT handle the how. That minimizes both latency and the potential for errors.
Keep it simple. Let the tool do the work.
Essentially, yes. Second, you absolutely have to manage costs proactively. These systems run continuously. So leverage serverless compute intelligently, and critically review those usage dashboards regularly. Look for optimization opportunities.
Any specific cost tips?
A big one is using spot instances for compute where possible, especially for non-critical transformation workloads in, say, the silver layer. That can often save you, upwards of 70% on compute costs.
Yeah, smart cost management and quality. You mentioned embedding that earlier.
Absolutely critical. You must implement robust data quality controls right within the pipeline using DLT expectations. These are rules, constraints you define, check for nulls, validate data ranges, enforce schema consistency.
And what happens if data fails a check?
DLT can automatically quarantine that bad data or halt the pipeline or just alert you, depending on how you configure it. The key is preventing bad data from ever reaching those critical gold layer tables that drive business decisions.
Stop the rot early.
Exactly. And finally, maybe the most important discipline. Test, iterate, and version everything. Use version control for your notebooks, your transformation code. Use MLflow experiments to rigorously test and validate model updates before you deploy them into production.
So standard software engineering discipline applied to data pipelines.
Precisely. That disciplined approach is what keeps a high-velocity system both reliable and adaptable, allowing you to innovate quickly without breaking things.
This has been a really insightful deep dive. So boiling it down, the core value we're seeing is unification, bringing storage, processing, analytics together, speed, getting insights in seconds or minutes, not hours or days, and intelligence embedding ML and AI directly into that real-time data flow.
Absolutely. And connecting this back to the bigger picture, making this transformation happen is becoming essential for staying relevant. This is where, again, a partnership adds significant value. We see the results directly.
Like the stats you mentioned.
Yeah, we help clients achieve tangible outcomes. Things like a 30% reduction in project timelines for complex data initiatives, particularly we see this in pharma. And maybe even more impressively, a 50% faster time to market for new data-driven products in areas like fintech and health tech.
Wow.
That's really how we at Canerica help organizations turn all this data complexity into a measurable competitive advantage.
So the real paradigm shift here, it seems, isn't just about faster reports. It's moving from systems that passively look back at history
Yeah,
to systems that actively inform the present moment and even predict what's coming next. Which leads to, I think, a crucial question for everyone listening.
go on.
How prepared are you, really, to move beyond just analyzing data to actually automating critical intelligence-driven decisions in milliseconds? Because increasingly, that capability isn't just nice to have, it's the prerequisite for leading your market.